Yes, in this video now we are going to see question number 21 onwards, the KCET chemistry solutions by YRK Mohan, Race Academy, Bangalore North. Okay, let us see that question number 21. Question number 21, we are doing D-1 code. Question number 21. What is the question is, on reacting 100 ml of 0.1 aqueous solution of CrCl3 6H2O with the excess of AgNO3, 2.86 grams of AgCl was obtained. What is the question is, CrCl3 6H2O. CrCl3 6H2O is there. This is 100 ml of 0.1 molarity. It looks definitely the coordination compounds chapter, definitely, and this is treated with the excess of AgNO3. This is treated with excess of AgNO3, getting a complex, and in this AgCl was obtained. What is the AgCl that is obtained? Is 2.86 grams. 2.86 grams they are giving. The clue for us is the plus a complex, whatever the complex is there formed. What is that complex is the question we have. So to solve this problem, we must know what is the exact number of moles of the complex formula which they are given, which is like CrCl3 6H2O. First of all, remember, whenever we have a complex is given with silver nitrate excess, the number of moles of AgCl is going to be formed when the chlorides are present in the ionization sphere. Means outside the coordination sphere the chlorides are present, means how many moles of chlorides are present outside the square bracket of the complex. Okay, x number of chlorides are there, x moles, that x moles is equals to the moles of AgCl. Clear? So from that we can easily find what is the complex. Let us find what is the AgCl. AgCl molar mass. What is the molar mass of AgCl is there? That is exactly 143. We can take 143.5, 143 grams per ml. If this is 1.143 grams per ml, then what about 2.86? We will find what is the number of moles of AgCl, that is equals to 2.86 by 143. So if it is 286, 2 times 2 by 100 is how much? 0.02 moles. So what it means, 0.02 moles of Cl minus ions are present outside the coordinate sphere of this complex. That means 0.02 means if you take this is 1 mole, that is 0.02 mole. So the question is very clear for that. In this square bracket is there, CrCl3 6H2O, you will write only one Cl inside, 5 waters and 1 Cl inside and 2 chlorines outside, and we'll sending one more water outside. This will be the answer from this number of moles. So here the number of moles is how much for the complex is 0.01 upon calculation. Molarity formula if you substitute, it will become 0.01. 0.01 is giving 0.02. That is because from this there are 2 moles of chlorides are coming outside. That is the meaning of this. So this is the correct formula of the complex which is to be identified in the options. That is the third option is the right option for that question. Okay, this is question number 21. Next, moving on to the question number 22. Also came from the coordination complex compounds isomerism. So they are given a formula CO NH3 5 times SO4. CONH3 5 times SO4 and one bromide, one bromine symbol given outside. Another complex formula given to us that is same thing, CONH3 5 times Br. SO4 they have given outside. SO4 they are given outside. What it means that there is an ion which is coming here is bromide and sulfate is coming from this ionization, means this gives Br minus, this gives sulfate, but both the formula are same, ions are different in the solution. It means it belongs to ionization isomerism. So this isomerism is nothing but ionization isomerism, and these two compounds are called ionization isomers. Ionization isomers. So that is the answer for this question. That is fourth option is the right option for this question. So these are 21 and 22 questions. Let's see the question number 23. Next we will see question number 23. What is that question number 23? Let us take down. Let us see our question number 23 in D1 code. Question number 23. That is, which of the following statements are true about cobalt complex CO F6 3 minus? This was one of the important example of octahedral complexes which we saw in valency bond treatment. Actually, it belongs to octahedral complex. Octahedral complex. So why it is octahedral complex means 6 is the coordination number, and at the same time the F minus is weak field ligon, we will get high spin complex. High spin complex means that whatever the d orbitals are there, outer d orbitals, the configuration hybridization is sp3. D2 configuration will come for this one. And another point under discussion is when the fluorine number is 6, that is the coordination number is 6, and X value calculation means oxidation state you calculate for chromium, cobalt in this one, which is equals to +3 will come. But whatever the one of the important statement here given, one of the statement, the coordination number of cobalt is 3, while that of oxidation state is +6. That is the wrong statement. These all statements are correct statements. Which is 3 statements are correct statements. They are nothing but 1, 3, 4 in that question they are given to us. That is the answer. Next, moving on to the question number 24, organic chemistry haloalkanes chapter. SN1 SN2 reactions are depending on. Usually we have SN1 and SN2 reactions are underwent by haloalkanes at a particular nature of the solvent is most important. Here nature of depends on, actually these reactions actually depends on nature of solvent. If that is present in that one, then you will go with that, because this haloalkanes undergoing these reactions on the basis of nature of the solvent which is used in that reaction. That is the option you have to go. This is the conceptual one from this haloalkane chapter. Next, question number 15. 2-methyl propane can be prepared by Wood's reaction. What is a 2-methyl propane? 2-methyl propane means on this 3-carbon chain alkane, we have second carbon methyl group is there. This 2-methyl alkane. Just carefully observe. What is Wood's reaction means? 2 alkyl halides to be taken, and the 2 alkyl halides will be treated with sodium metal to get the alkanes. This is one alkane. This alkane can be obtained when we have taken chlorines this side and this side. Then what is the formula here is one is CH3Cl, another one is Cl CH3 CH3. This is what? This is nothing but chloromethane. Its name is chloromethane. This is chloromethane, and this is 2-chloropropane. Its name is 2-chloropropane. propane. If we take sodium metal by taking these two different alkyl halides, definitely we will get the compound name, that is 2-methyl propane. 2-methyl propane. This is going to be obtained in Wood's reaction when you take sodium metal in this one. The reverse reaction is nothing but Wood's reaction. That is question number 25. We have correct option is chloromethane, 2-chloropropane for this question. Question number 25. Let's move on to question number 26. What is that question number 26 they are asking? The question number 26 they are asking. There is a scheme of the reaction they are given, and in that we have to find what is the reagent present on the arrow mark. Okay, let us see this equation, the scheme of the reaction, that is C2H5Cl they are given. In this, there is one scheme of the reaction X given here. They are not telling what is X. It is giving C2H5F. C2H5F. Similarly, they are giving Y on the arrow mark, and they are giving CH2 double bond CH2. Next, they are giving Z on the arrow mark, which is C4H10. So what might be X, Y and Z? So carefully observe, halogen chloride is there and fluoride came. Fluorides are prepared using Schwarz reaction. In Schwarz reaction, we can use heavy metal fluorides. That if you just check it in the options, one of the heavy metal fluoride, we have silver fluoride is available. We have silver fluoride is available, and mercurous fluoride is also available. Okay. Whereas we have alcoholic KOH is also available. Okay, so this one is coming when we have that reaction, named reaction called as Schwarz reaction conducted. So when hydrogen halide is removed in the presence of Y, then this is called as dehydrohalogenation. Dehydrohalogenation. When the two alkyl halides taken in the presence of sodium metal and ether, we will get enalkanes, that is Wood's reaction. That is Wood's reaction. So what we can understand here is nothing but you just carefully select the options where in one of the option we have one of the heavy metal fluoride is there, Hg2F2 we can select, and Y is nothing but dehydrohalogenating agent, alcoholic KOH. Alcoholic KOH, and Z is nothing but sodium metal in dry ether. So Wood's reaction 2 times repeated, I can say, in this examination of 2 questions they have asked from different chapters. So this is mercurous fluoride, Y is alcoholic KOH, Z is sodium metal in dry ether. That is the question scheme of the reaction they have given in question number 26. Let's move on to question number 27. What is the question number 27 is they given 8.8 grams of monohydric alcohol which is added to ethyl magnesium iodide in ether liberates 22.2240 centimeter cube of ethane at STP. This monohydric alcohol when oxidized using pyridium chlorochromate is producing the carbonyl compound that gives the silver mirror test they are telling. So what might be the alcohol? That is the question. So in reading the question, on checking the options we have is a verification method. In that, usually what we understand is nothing but an alcohol, if you take alcohol is treated in the presence of PCC, that will convert it into carbonyl compound, particularly that is aldehyde carbonyl compound if it is primary alcohol. Why? Because why I am telling aldehyde means this will only corresponds to gives positive test with the silver mirror test. That means this give Tollin's reagent test. I can simply say that this will give Tollin's test. it will give tolerance test positively. So that means you have to select the primary alcohols in the list. In that one of the primary alcohol we have, that is 2, 2 dimethyl propane 1-ol, which is satisfying the whatever the value of the number of moles of this alcohol. 2, 2 dimethyl propane 1-ol. It is nothing but yes, like this will be there, CH3. Here CH3 is there. Here CH3 is there. Here we have CH2OH is there. There are 5 carbons are there, and there are 12 hydrogens are there. C5H12O is there. That too, it is a primary. Then it is said to be giving the carbonyl compound with aldehyde gives tolerance positive test with a molecular weight exactly equal to 88 grams, which we have already calculated. So if you got the same molecular weight for any other substance in the options, that is not going to be the right one, because only one primary alcohol here given in the options which is satisfying this molar mass as per the problem. So 88 grams and 2240 centimeter cube, these all number of moles calculation. Only that number of moles calculation if you do, that looks like a new whatever the mole concept related thing. But in this how you can understand is nothing but the positive tolerance test is possible with the alcohols, primary alcohols, and checking the 2 primary alcohols or 3 primary alcohols given the options with satisfying this molar mass. That is the right option. Question number 27, we have 2 dimethyl propane 1-ol is the right answer because of this whatever the reasons. Next, we will go to the question number 28. So next thing is we have question number 28. So what is the question number 28 is the tertiary alcohol, that is a C4H10O, reacts with 20% of H3PO4. They given C4H10O, that is A, is react with 20% of phosphoric acid and gives B its formula C4H8. B is the C4H8 formula given. The major product, what is the IUPAC name of B? So they are asking what is the IUPAC name of this B. First of all, you carefully observe what is this tendency of H3PO4. H3PO4 is nothing but a dehydrating agent. Here, whenever they given an alcohol, they are also telling this alcohol is tertiary alcohol. So if you make it tertiary alcohol, so 4 carbons like this. Here now one OH if you write, this is CH3, this is CH3, this is CH3. In this one of the CH3 you take it as CH2 and take one hydrogen separately, and you do one process called as the dehydration. Then what will come, you check it, that is CH3 CH2, here one more CH3 will come. What is this one is nothing but on the second carbon methyl group is there. So you can write here double bond, this you can make it as CH3, both are same only. So on the second carbon what is there, methyl is there, it is called as 2-methyl, this is propene, 2-methyl propane. So 2-methyl propane is the right answer for this question number 28. In this the entire phenomena is nothing but dehydrating agent. Dehydrating agent. So I have already told some of the dehydrating agents are there. You select dehydrating agents. If sulfuric acid is not given, if phosphorus pentoxide is not given, this phosphoric acid 20% is also working the same way like that of sulfuric acid. Next thing, question number 29. Moving to that question number 29. So what is the 29 is the PCC is. What is PCC? Directly asked. So in the previous question, the problem where they have told PCC, here also PCC 2 times given. What is PCC stands for? It is nothing but pyridium C stands for chloro. Another one is stands for chromate. Pyridium chlorochromate. What is pyridium means? Pyridine is a 6-membered ring, and with the positive charge is there, that we will call it as pyridium. And chlorochromate. What is chromate means? CrO3 with Cl mixed one, that is chromate. That means CrO3 is there. There are 3 oxygens are there in this, and one of the chlorine is present in this one, means that one oxygen gets negative charge. That is called pyridium chlorochromate. It is matches with a complex of chromium trioxide with pyridine and HCl. So what is this? Pyridine is there. Here pyridine is there, and chromium complex, that is chromate, is there. HCl is there. Their mixture we will call it as pyridium chlorochromate. Pyridium chlorochromate. That is the answer. Next, question number 30. Next we will move to the question number 30. What is the question number 30 is propanone and propanol are. Propanone and propanol are. Question number 30 easily given. One name given is propanone, another name given is propanol. They are what type of isomers? Is a question asked from isomerism. Isomers. So both are carbonyl compounds. One is ketone, all is aldehyde. Prop means 3 carbons. So 3 carbons. Ketone is nothing but acetone or propanone. And 3 carbon aldehyde is propanaldehyde, that is CH3, CH2, CHO. Both are having same formula. How many carbons? 3 carbons, 6 hydrogens, 1 oxygen. Formula is same, but this is ketone, this is aldehyde. That's why they are called as functional isomers. They are called as functional isomer. This is ketone, is functional group. Here the functional group is aldehyde. So these are nothing but functional isomers. What is their function? Their names are nothing but they are known as functional isomers, and the phenomena is called as functional isomerism. Okay, dear students. Next one, question number 31. We will see question number 31 also. They are given sodium ethanoate on heating with soda lime gives X. Sodium ethanoate is what? CH3COONA, and soda lime they have taken. Soda lime, what is this function? Is nothing but abstracting CO2. So it will gives methane. That is nothing but the X which they are expecting in the equation. Another compound they are given is electrolysis. X on electrolysis, aqueous solution of sodium ethanoate. So this is sodium ethanoate. Electrolysis gives Y they are telling. Sodium ethanoate is what? CH3COONA. If you take this one 2 moles and you do hydrolysis, electrolysis, then you will be getting ethane. That is ethane is C2H6, and also carbon dioxide is going to be liberated. At the same time, sodium hydroxide is formed, along with the liberation of hydrogen takes place at cathode. So what is Y? They asked. So Y is ethane. So what is X? X is methane. And what is Y? Y is ethane. X is methane. Y is ethane. This is the first option. That is the right option for that question number 31. Next, moving on to the next question and the last question in this session we have, that is question number 32. We will see question number 32 to conclude this part of this discussion. Question number 32. What is the question is? Butane on reaction with dilute H2SO4. Butane. What is butane means? CH3, CH2, C, triple bond CH. So that is butane. Butane 1 given. So that way we wrote but 1 ion. So but 1 ion, a triple bond is there, and they are telling that is treated with H2SO4 in the presence of mercuric ions at 333 Kelvin. So 333 Kelvin means 60 degrees Celsius. So it is something like hydrolysis only. Here what we are going to do is nothing but we are going to add water. So hydrolysis reaction is going to take place in this. From water, H plus will come and OH minus ions also will come. It follows the Markovnikov rule, in which the less number of hydrogen attached carbon, that means carbon with less number of hydrogens will be receiving the negative part of this addendum is water. After that, any rearrangement takes rearrangement will produce the final product like carbonyl compounds. If you write this one, CH3, CH2, C, OH will come, OH, and the triple bond will become double bond. This CH will become CH2. Okay, next there is a tautomerization takes place, dynamic process, that means rearrangement, CH3, CH2, C double bond O, CH3 will come. This is ketone. This is a tautomerism takes place. This is ketone. This one in bond-like formula they have provided that bond-like formula is similar to this whatever we got here. This is the this one and this one both are same. So this is one of the reaction of hydrocarbons. There is alkynes reaction they are given, that is converted into carbonyl compound ketone. That is the right answer. That option for this one is the first option, the right option for this question, number 32. Okay, we will see the remaining questions, next questions in another discussion. Have a nice day. Let us check with that all these questions what we are given. You can mark the right options and you check with whatever we discussed earlier also matches with this one or not. Thank you.